Hi everyone. Today we're going to be looking at we looked at the anterior and posterior pituitary with the last lecture. Now we're going to look at the thyroid and parathyroid glands. So we're going to look and see what hormones are secreted by these glands and what they do. So this is a picture of where your thyroid gland is. It's a butterfly-shaped organ, and you can actually feel it underneath your larynx or your voice box. Which is really cool. We'll do that in class. So this is the organ that we're interested in right now. So if I look at a section under the microscope, I would see something that looks like this. Actually, let me show you an actual picture. This is what it looks like, okay? So you have a colloid on the inside of the follicular cells that line it, and then you also have parafollicular cells. And each type of cell is going to secrete a different hormone. So a drawing of what this looks like is this. Here's your follicular cells, here's your colloid, and your parafollicular cells are on the outside. And remember that your endocrine organs are going to have a lot of blood vessels going through them because that's where the hormones travel through. So all of this yellow with the red blood cells in it, that's your blood vessels. So let's look at the first hormone that we need to look at. It's thyroxine, or T3 and T4. They're slightly different in their makeup. T4 has 4 iodines on it, so iodine is very necessary, and T3 has 3 iodines on it. The gland source is the thyroid, and T3 and T4 are going to target all of your body cells because it's going to enhance metabolism for these cells. Now, how does T3 and T4 get released? Your hypothalamus, because it's got all of these blood vessels moving through it, is going to detect whether or not we have normal levels of T3 and T4. If the levels are low, it's going to release thyroid releasing hormone. That hormone travels to the pituitary gland and causes the pituitary gland, and remember it's the anterior pituitary, but causes the anterior pituitary to release thyroid stimulating hormone. And this is all controlled by negative feedback. So whenever there's a normal amount of T3 and T4, we will no longer need the release of T3 and T4, and so the whole system will turn off or slow down. So we do have individuals that have problems with their thyroid gland, and it may not necessarily be their thyroid gland, it could be the pituitary gland, and we'll talk about that later. But you can have hypothyroidism or hyperthyroidism. And there's a few different types of hypothyroidism and issues that can arise from that. One is if I have low levels of iodine, I'm not getting enough iodine maybe in my diet, then I could form what's called a goiter, and I'll show you a picture of that later. Cretinism is when I have low T3 and T4 levels in children, and myxedemia is in adults. Again, low levels of T3 and T4. If I have high levels or hyperthyroidism, that could result in something called Graves' disease. And again, we'll talk about these in class. So just to kind of show you the cells that are going to release T3 and T4, it's your follicular cells. So your follicular cells have the receptors that will respond to TSH from the thyroid or from the pituitary gland. They will release T3 and T4 in the colloid, and then T3 and T4 in their final form will leave into the blood vessels. Alright, so the thyroid also releases a hormone called calcitonin. And calcitonin is really important for the maintenance of calcium levels in the blood. Again, it's coming from the thyroid, particularly it's coming from your parafollicular cells. The target is your osteoblasts and osteoclasts. And so what happens, remember osteoblasts are bone building cells. Because calcitonin targets those osteoblasts, it uses the calcium to help to build bones. So I'm storing calcium. And this is when I have higher levels of calcium in the blood. I want to store that calcium for later. The other thing is that your intestines are targeted because if you have high levels of calcium in the blood, you don't need any more, and so it turns your intestines off from absorbing the calcium. Again, we have another negative feedback mechanism going on. Whenever I don't have enough calcium in the blood, the system will be turned off when I have enough calcium. And so again, looking at these pictures, calcitonin is made by your parafollicular cells. That calcitonin will then leave into the bloodstream and go target the cells that they need to target. All right, so let's look at your parathyroid glands. Your parathyroid glands are embedded in your thyroid gland, and they're actually on the posterior side of the thyroid gland. And so that's interesting to know. We didn't know about these thyroid gland or parathyroid glands because they are kind of small and on the back of the thyroid gland. All right, so parathyroid hormone is produced by the parathyroid gland. You might also hear them called parathormone. The target for this hormone is your osteoclast, kidneys, skin, and intestines. And if you remember from our bone or skeletal unit, we said that osteoclasts break down the bone. So when there isn't enough calcium in the blood, your parathyroid glands pick that up, release parathyroid hormone, and that causes your osteoclast to break down bone to release more calcium in the blood. It also triggers your kidneys to keep calcium rather than releasing it into your urine, and also increases the production of vitamin D so that way your intestines can absorb more calcium. So again, the reason why parathyroid hormone would be released is because your parathyroid glands are picking up the fact that you have low levels of calcium in the blood. So calcitonin and parathyroid hormone are both examples of humoral release mechanisms. Just like with calcitonin, parathyroid hormone is a part of that negative feedback mechanism where you have when there is enough calcium, parathyroid hormone will no longer be released. Some problems that we see: tetany and osteitis fibrosa cystica, and we'll again talk about these in class. So just to kind of review this negative feedback mechanism is whenever I should have about 9 to 11 milligrams per 100 milliliters of blood circulating. If I need to decrease my levels of calcium in the blood, calcitonin will be released, and that will bring my amount of calcium back in the blood because I'm taking calcium out. If I need to increase my levels of calcium in the blood, PTH will be released and I'll break down some bone. All right, that was a relatively short lecture. I hope you got something out of it.